Hello everyone, so we are continuing with the chapter Boolean algebra, and in the previous video also I discussed about K-map, Carnot map. So today also we'll continue with K-map. So today we'll discuss about pairing reduction methods. So reduction methods using K-map to simplify the Boolean expression. So we can further simplify the Boolean expression using different pairing reduction methods. So the first one is pairs. As you can see in this K-map, you have two pairs of ones. So this forms a pair. So in pair reduction method, we can pair or group the variables of adjacent cells that has value 1. So while grouping, the grouping of the pairs has to be the value 1, not 0. So in grouping, you cannot take the value 0. It has to be only 1. So 0 represents, in terms of mean term, the complement, right? So it is possible to have more than one pair. So as you can see here, you have two pairs in this K-map. One is horizontal and the other one is vertical. So pairing of adjacent cells can be done horizontally or vertically. So according to the value assigned to the variables, so these are the variables of the literals. So these are the values that are assigned. So when you have four variables, these are the values, and the combination of rows, and the combination of mean terms it can form. So to the variables in K-map, the mean term will be positions. So the mean term will be position based on that. So according to the truth table, the values that are formed, the mean terms will be positions. So this might be m0, this might be m2, this might be m1, and so on, right? So comparing the two paired mean terms, the variable which changes from uncomplement to complement is eliminated. So this side you have xy, so this is x and this is y, and this is zw, so this is z and this is w. So this one it forms one mean term, that is xyzw, and this forms another one mean term, right? So when you compare the two mean terms, the variable which changes the form, that means which becomes complement, it becomes eliminated. So to get the Boolean function, we OR the two paired mean terms after the variable gets eliminated. In pairs, only one variable gets eliminated. So after we formed the two paired mean terms, it gets ORed to get the simplified SOP expression. So here is an example. The following K-map contains two pairs, horizontal and vertical adjacent cells. So only the adjacent cells will be paired. If there is the in the adjacent cell 1 is there, 1 is there. So here horizontally the literal 0 is complemented. So wherever the value of variable is 0, that variable will get complemented. So in here the first mean term, that is x complement, y complement, z and w. So if you see horizontally, this first value 1, this is 0, so x complement 0, y complement, and here 1 1, so the variable remains same, zw, so it represents 1. And then the second mean term, that is this one, so x complement, y complement, and then z is 1, w is 0, so w complement, so it represents 1. Now so in here, when you see this mean term, you can see that in here, comparing this and this, only w changes its form from w to w complement, right? So hence w gets eliminated. Similarly, vertically, if you see this here, you get the mean terms, that is x complement, x complement, y complement, x complement y, and in this one z complement w, this, right? And in the second one, so you have x y and then z complement w, so which represents the second one. So now if you see there, x changes, y remains same, z remains complement in both mean terms, w remains same, only x changes to x complement, so x is removed, so the rest will remain the same, so x gets removed. And then what we do is that the reduced mean term, we OR the two mean terms. So we in here we OR the two mean terms, which will give the reduced SOP as f equals to function equals to So here in the first one, since we remove w, so we'll get x complement y complement z plus, since we are ORing it, right, then y z complement and w, right? So this way we can reduce the mean term and we can reduce the expression, so SOP expression. Similarly, we can also do it for POS, for max term. So the advantage of this is that, see, we try as much to reduce the Boolean expressions using mean term, max term, SOP, POS, truth table, logic gates, K-map, like that, so on, right? So this is to eliminate the use of the, because this Boolean algebra is all about designing the logic circuits, right? So this reduces the design of the logic circuits, the complexity of the logic circuits. So that way we can simplify the design of the logic circuits. Clear? Now, next one is quads. So in quads reduction method, we can group 4 variables. So we can group 4 variables of adjacent cells that has value 1. So quads will eliminate 2 variables. So the number of variables here, it may be 3, it may be 4, but here what it says is we can group 4 variables, means the input values, okay, the number of input ones grouped. So here you can see that horizontally and vertically 4 number of ones are grouped together. So in quad we will eliminate 2 variables. So here horizontally, if you can see that the value of x and y for all the cells remains unchanged, that is 1. So x, y. But for, if you see the value of z and w, here it's 0 0 0 0 0 0 1 1 0 1 1 0. So you can see that z and w in all the cells, it changes. So it changes its form. So z and w will be removed. So the reduced SOP expression becomes f equals to xy. So only, since 2 variables will get removed, so we have only x and y. So that is using the quads. Similarly, vertically also, if you see vertically, z and w value remains the same, so it remains unchanged. However, x and y, it keeps on changing. It becomes complement x complement y complement. So reduced SOP expression becomes f equals to zw, right? So that way you remove 2 variables. So now the expression gets reduced. So the complexity of the logic circuits also reduces. Now also it can be paired in this format. So as you can see in this diagram, we have 4 pairs in a cube in square format. So if you see here, horizontally x changes from 0 to 1, but y remains 1 1, and so x changes and x is removed. And vertically, if you see, z changes from 0 to 1, but w remains 1 and 1. So z is removed. So the output is the reduced SOP, which becomes f equals to y and w, because z and x is removed. Okay. Now again we have another quad formation. So this type of quad pairing, it is also called as map rolling. So whenever we have isolated number of ones like this, okay, in any of the cells, okay, not only in here but in any of the cells, so which is isolated. So here if you see the mean term, so this is the mean term formation. So this x complement, y complement, z complement, w complement represents this, okay, plus, since we are ORing the mean terms, right, this is SOP, sum of products. So this one, x complement, y complement, z w complement, represents this, that is x complement, y complement, z is 1 and w is 0, so w complement. So like that, this and this also is plus plus. So now what we can do is that we can pair these isolated ones by rolling the K map. Okay, we can roll it so that the bottom it touches the top and then the left touches the right. Okay, so that way the pairing is done. The pairing is done uh, between the four ones. Okay, so at the end of this the simplified expression will be, so you can see that y complement w complement, because if you see there x value here x value changes from 0 to 1 but y remains same, and if you see here z value changes from 0 to 1 but w value remains the same, 0 0, so which is the complement 0, and here also 0, right, complement. So that's why we get f equals to y complement w complement, right? So map rolling is also important. Now the next one is octet. So in octet reduction method we can group 8 variables. So as you can see here, 8 variables values, input values are grouped together. So here 3 variables gets eliminated, right? So out of these 4 variables only one variable will be taken. So horizontally if you see x is 1 1, y is 1 0, so y gets eliminated, x remains unchanged. And if you see here the value of the z and w, it also changes from 0 to 1 and 1 to 0, so w and z are also removed, so the reduced SOP expression becomes f equals to x. Okay, so in octet only one variable is taken as the output, right? So study this formation K map. Okay, these pairs, quads, octets, okay, the map rolling, and in the next class we'll discuss more on this K map, right?